Good morning, friends. Today we will talk about combustion in the spark ignition engine. Today we will see how actually fuel burns in the petrol engine. Okay, so in the theoretical, we have assumed that the fuel, or we can say the spark, is occurred exactly at the top dead center. Okay, exactly at the end of compression stroke, and the fuel will burn spontaneously, so the pressure will increase exactly at the top dead center. That we have assumed in the theoretical cycle, right? But in the actual case the scenario is little bit different. So today we will talk about how actually the fuel burn in the petrol engine. Okay, so generally the combustion process in the IC engine might be divided into the three phases. The three phases are the ignition leg, or we can say delay period. The second one is a flame propagation, and the third one is afterburning phase. We can see in the graph also, A to B phase is known as the ignition leg phase, B to C phase is known as the flame propagation phase, and after C it is a afterburning phase. So we will see these three different phases in detail. So the first one is the ignition leg. So this will start from point A. Okay, when there is a spark, it occurs little bit earlier than the top dead center. In the theoretical, we have assumed that the spark is occur exactly at the top dead center, but in actual the spark is occur some degrees before the top dead center. Okay, so at the point A there will be a spark, right? So the phase 1 is also called the ignition leg or the delay period. Why it is known as the delay period? Okay, so we can say here point A to B. These phases start from point A when the spark is occurred, and the point B. Now point B is, it is a deviation of the combustion curve from the motoring curve. This is known as the motoring curve, and this is our combustion curve. So when these two curves are deviated at this point, it is known as the point B. So area between point A to B is known as the ignition leg phase. Okay, now these A to B phases depend on the different factors. Okay, the first one is the fuel. Okay, so the higher the self-ignition temperature of the fuel, longer is the ignition leg. If the self-ignition temperature of the fuel is higher, then it will require a more time to ignite. So the ignition leg period will be increased. Okay, so the first factor is fuel. Okay, the second factor is a air fuel ratio. Here we can see in this graph, it's a fuel air ratio. Okay, one, that means what? It is the stoichiometric mixture. Okay, one from beyond this point, the mixture will become a rich mixture, and in this region the mixture will become a lean mixture. So the minimum time required is at exactly 1.2. When the fuel air ratio is 1.2, that means the mixture is slightly richer. At that time, this period or this phase will be shorter. Okay, after then, rich or lean, the ignition leg period will be increases. Okay, so second factor is fuel air ratio. The third phase is, or we can say the third factor is the initial temperature. Okay, if the initial temperature is higher, then we can say the time required, it is also decreases. Okay, so higher the initial temperature, it will require lesser time to ignite the fuel. Okay, so these phases depend on the three factors. The first one is the fuel, the second one is the fuel air ratio, and the third one is the initial temperature. Okay, now we'll talk about the second phase. Okay, so the second phase is starting from point B to C. The B point is what? It is the deviation of the motoring curve from the combustion curve, and C is the point where the pressure is maximum. It is a peak pressure. The peak pressure is generated after some degrees from top dead center. Okay, the time required for this phase depend mainly on the intensity of the turbulence. Okay, if we are providing a turbulence, then it requires less time. Okay, so the time required for achieving the maximum pressure, that is depend on mainly on the turbulence. Okay, now this is the third phase. Beyond this point, here we are getting the maximum pressure, but after that point pressure will decreases, but the temperature will increases. Okay, after this point, here the pressure is maximum. Beyond this point, what will happen? Pressure will decreases, but the temperature is increases. So this is the third phase. Okay, here it is a maximum pressure, and after that, somewhere here we will get in the maximum temperature. Okay, so from C to this point D. Okay, so this phase is known as the afterburning phase. Clear? So now actually what happened, after the front flame has reached the cylinder walls, there will be about 25% of the charge still not completely burned. Okay, so at this stage it becomes difficult for the remaining oxygen in the charge to react with the petrol vapor, so that what will happen, the rate of combustion will be slowed down. Okay, so this condition is known as the afterburning condition, right? So at the same time there will be a heat liberated due to the chemical interactions caused by the reassociation. Generally what happen in the dissociation, what will happen, it will absorb the heat, but in case of reassociation it will release the heat. Okay, so during the reassociation what will happen, it will release the heat, so the temperature will be increases from C to D. Clear? So during the expansion stroke the exhaust temperature will be increases. Clear? So I hope you guys understand all these things. Thank you so much.